Okay, guys, we're back for more section 2. Section 2, atoms, molecules, and ions. My name is Justin from chemistrynotes.com, and this is video number 3 from section 2. So today is mainly going to be about something called isotopes. But before we talk about isotopes, we want to talk about a brief introduction to modern atomic structure. So, top of page 1 of our notes. A brief introduction to modern atomic structure. Now, we'll go into a lot of detail on atomic structure in section 7, but for today, we're just going to kind of get the ball rolling and then move into isotopes. So, a lot of this might be review for some of you, but atoms have 3 components, right? They have an electron, they have protons, and a neutrons. So, electron, we give it the symbol E minus. It has a mass of 9.11 times 10 to the minus 31st kilograms. And the electron has a relative charge of -1. Proton, P to the plus, is 1.67 times 10 to the minus 27th kilograms, relative charge +1. And the third one there are neutrons. Neutrons have a little n and the superscript 0. Same exact mass as protons, 1.67 times 10 to the minus 27th kilograms, relative charge 0. Now, at first glance, all 3 of those masses just look like, oh, they're all 3 are really, really small. But what you have to pay attention to is 10 to the minus 31st versus 10 to the minus 27th is actually a big difference. It's 10,000, okay? The electron's mass is 10,000 times smaller than the mass of a proton or neutron. This is why in the last video we said the nucleus was like 99.99% of an atom's mass. Electrons are so much smaller than protons and neutrons that their mass is actually insignificant. Okay? So in the nucleus, which contains protons and neutrons, accounts for essentially quote unquote all of an atom's mass. The electron's contribution to mass is negligible. All right? Okay, so moving on to page 2 of today's notes. We're going to start this page by asking a question. So let me set up the question here. The question reads, if all atoms are composed of protons, electrons, and neutrons, how come different atoms have different properties? In other words, if everybody is nothing but protons, electrons, and neutrons, how come different atoms, for example, lithium versus chlorine, how come they have different properties if they're made of the same stuff? All right? Well, the answer to that question lies in the number and arrangements of electrons going around that nucleus. Okay? So let's read that kind of in real time. Question, if all atoms are composed of protons, electrons, and neutrons, how come different atoms have different properties? Well, the answer lies in the number and arrangement of electrons, which interact with other electrons from other atoms when they combine to form bonds and molecules.